All right, so the Polygon section that we're in right now has one special theorem that we're going to look at. So we're going to start with the try this question right here. This is at the middle of page 3. And so what we're going to do is we're going to draw a polygon that has 4 sides. And we're going to see how many triangles I can make without crossing over different diagonals. So for example, if I draw one here, I now have 2 triangles, 1 and 2, inside of this shape. And so if you look at the shape, the number of triangles has to do with how many degrees the interior angles of a 4-sided shape creates. If you look at a 5-sided shape, like this, you can draw these same triangles by connecting different vertices. You'll notice that we have 3 triangles in this one, 1, 2, and 3. So the number of triangles in the shape is equal to the number of times you multiply by 180. There's 180 degrees within each of these triangles in terms of their interior angles. And likewise in here, there's 180 degrees as well. So if you add up all the 180 degree measures together, you get the total angle sum of the interior angles in a polygon. So for a 4-sided shape, we have 2 times 180, which equals 360. And for a 5-sided shape, we have 3 times 180, which equals 540. Now, thinking of this way of measuring this is very, it's kind of random at this point in time, but this relates back to the number of sides that the shape has. If this is a 4-sided shape, the 2, the number of triangles, is 2 less than 4. 4 minus 2. The 3 for a 5-sided shape is 5 minus 2. So if you take the number of sides and you subtract 2 from it, all you have to do is multiply that number by 180 and you get the total interior angle sum. And that is outlined in Theorem 6-1, Polygon Angle Sum Theorem. The sums of the measures of the interior angles in an n-gon, or for instance, any shape that has a certain number of sides, is n minus 2 times 180, where n is the number of sides or angles. So if you take this n minus 2, by the way, just to connect it back to the above problem, we have the number of triangles in the shape is equal to n minus 2. So let's try this with any number of sides. For example, the sum for a 20-gon is simply going to be n minus 2 times 180. And so n is 20 here. So we're going to plug in 20. And now we just simplify and continue to solve the problem. This is going to be 18 times 180, which equals 3,240 degrees. That is the total angle of the total sum of the interior angles in a 20-gon. You can flip the script, and if you're given the sum, you can actually solve for the number of angles in the shape, or actually name the shape itself based on how many angles you have, or how many sides you have. So this is where, in letter B, if 1080 is the measure of all the angles, I can make that the sum and equal that to this same formula, n minus 2 times 80. If I were to actually solve for n, I can divide both sides by 180, which leads me to 6 equals n minus 2, and I add 2 to both sides, n equals 8. So if I have an 8-sided shape, this is an octagon. Okay? So if you continue to try the next two questions, you can see, first of all, what the sum of the angle measures for a 16-gon is, and then what the name of the shape is for a polygon that has a sum of 1440. So go ahead and try those two questions on your own. Check the key to see if you can get it correct, and we will stop there for right now.